In this video, I'm going to show you how to calculate your regression equation. So we're going to start with some data, and again, regression, we're trying to figure out the degree of relationship between two variables, and remember when you're doing regression and correlation, you either got to have interval or ratio data. So let's say that we're working with this data set over here. We've got 12 different people's years of education and the level of prestige in the job that they have. Usually when you're doing regression, that means you've already calculated a correlation coefficient and you've already gotten these summary statistics. So you would want to go ahead and start by finding out what's the sum of all your x's, your squared x's, the mean of your x, same things for your y. We need this covariance number right here, which is again where you take every single x multiplied by every single y, and that product is called the xy factor. And so the last thing you would do is add up all of your xy's. And then N for correlation and regression both is just the number of pairs in your data set, which is just really indicating how many people did you have in your sample that you got this data for. We've got 12 pairs of numbers, so our N is 12. So let's say that as a first step, you've already calculated your Pearson R, your correlation coefficient, and you got an R of 0.63. So we know that there's a moderately strong positive correlation between these two things, which really means as your education goes up, generally so does your job prestige, which is interesting to know. If we want to see really what that picture looks like, we need to come up with an equation for your regression line. So when you actually graph your correlation and you put the little dots on the graph, you're trying to draw a line through it that minimizes the distance between each of the dots and the line. So that's why we call it a line of best fit. You can't just slap a line up there wherever it looks the best. There's actually a formula that we use to calculate where the line exactly goes. And this is going to give you some algebra flashbacks, slope and y-intercept kinds of things. So step one is we're going to find the slope of that regression line. And we call the slope B. The formula for the slope is going to look really familiar for the most part if you've already calculated your correlation coefficient. This part on the top of the slope formula is the exact same as the top of your correlation equation. So if you've already calculated that, you can just substitute the number on the top of the fraction and slap it down on the top of your slope equation. The bottom of the slope equation also comes from how you calculated your correlation coefficient. That is going to be really just the first part of the formula on the bottom. So this is the first part that was in brackets underneath the radical in your correlation equation. So now you just need to start plugging in here and substitute so that we can calculate the slope. And the slope is telling you how slanted up or down is your line and whether or not it slants up or down. And then when we plug this in, that's the top, and on the bottom, when we reduce, we get a slope of 0.7156. So what that means, we've got a positive slope, which we should have expected to get because our correlation coefficient was also positive. So we know our line is sloping up. Now, once we have the slope, we need to figure out where does our regression line actually hit the y-axis. That's what we call it, the y-intercept. And we call the y-intercept, we use a little lowercase a to denote the y-intercept. And this is where the means that we got for our two variables comes in. When you're calculating the a quantity, we use our mean of y. So the mean of all of our y scores, which is the job prestige, is y, minus this slope that we just calculated times our mean of x, which is, again, that's the average of all of the years of education. And these are just coming from these quantities that I already gave you over here. So just plug and chug, plug those in. And then this is the slope that you just got in the previous step. And I would recommend, again, anytime you're doing a calculation that involves multiple steps, You don't want to round off a lot in the intermediate steps because it's going to affect. So like if you rounded to 0.72 here and you're using 0.72 for your slope, that's going to give you a different y-intercept than somebody who carried it out to 4 decimal places. So leave those in there. And we get a y-intercept of negative 3.32. So don't panic if you get a negative y-intercept. All that means is that your regression line is actually hitting the y-axis below the x-axis, which doesn't mean you've made any mistakes or done anything wrong. That's perfectly normal thing to do. Now what you need to do is put both of these quantities into your regression equation, which is how you kind of predict values of y based on x. So the way your regression equation works is we use y prime. And y prime means predicted values of y. It doesn't mean actual observed values. It's just this is what we would expect given this x. So we plug in our slope first, x, and then the y-intercept comes after it. And since our y-intercept was negative, we do a subtraction. And what this equation does is it's like a prediction computer for your data. It's saying, based on what we know about the relationship between those variables, if you give me anybody's years of education, I can predict what their job prestige is going to be. So if I put in an x of 2, I could reduce that formula and it would spit out a predicted y. And getting those 2 predicted y values is actually how you connect the dots and draw your regression equation on your graph. So you would have your data that looks something like this. Here's your x, here's your y. You pick 2 x values, and it doesn't matter what x values you plug into the equation. It just has to be x's that make sense. So if we're doing years of education, we're going to probably want to pick x's that are somewhere between 10 and 20 because that's where most of our x's seem to lie. So you pick 2 x's, you plug them in, and then it'll spit out a predicted value of y. And that's how you get your 2 dots, connect, and draw your line through your graph. And once you have that, it's basically an all-purpose prediction machine that you can use to predict at any given value of x what the predicted job prestige would be. And that's the final step in doing your regression.